right, welcome to example 2 as we are writing these problems and then solving them, applying different principles of math that you've looked at really for many years as you've been solving problems. So let's get right into this. Example number 2 says John has $21.61 balance on a gift card that can be used to purchase online music. Each song downloaded costs $1.29. John wants to maintain a $10 balance to purchase a new album that releases next month. How many songs can John purchase? Let's jump over to a blank screen and look at some of this information. So we heard about the fact that he has some money on a card, and I'll double check that. Oh man, my memory is going. I apologize. All right, got that fixed now. I probably still did it, didn't I? No. Okay, hit in the game. All right, so he has that amount, and it says that he needs to save at least that much. But he is going to buy some songs, and it's $1.29 per song. So I'll just say S for song right now. So we're looking at that idea. Now, as we go back to this word problem, I know the example already shows you the understanding of the equation here, but really we can think back to some different patterns that we've had. In the past, we talked about this way back at the beginning of the year, talking about different patterns to recognize. And what we do see is we see that John has a beginning amount. He wants some to go away, but he wants this to remain. He wants this $10 to remain. And so as we look at that, we can see that pattern. We call that our bar pattern. He's trying to establish that, right? Beginning amount, which is going to point to this. Sum is going to go away, which is actually pointing to this whole quantity here. And then what it remains is going to be this. And so as we look at this, we can go ahead and create this equation then that says 21.6 minus the quantity 129 times S equals $10. Right? And so I threw parentheses in there because I did, but we really don't actually need those there. So I'm just going to get them out of the way so we're not confused. And I think I'm actually going to change the variable to just so we have a clear understanding. So that was a 29, and let's make this I'm going to make this M. That way we can clearly see the numbers. All right, so the goal here is to get M alone now. So what do we need to do to get M alone? So the first thing we want to do is start by combining like terms. The problem is we have this equal sign here, and since we have the equal sign here, we have to use the rules of equality and the inverse operation to do things. So what that means is we're going to look at our numbers. So we're going to start by looking at this number, and we're going to say I want to do the opposite so I can combine it on the other side of the equal sign. So if I have a positive, right, $21, I need to subtract it from this side to eliminate it. So 2161 minus 2161 equals 0. So now I'm left with 0 minus 1.29 M. And then on the other side, right, since I subtracted this 2161 here, I also have to subtract 2161 here. And so this is a positive 10 minus 2161, so subtracting 2161, so that's actually going to give me a negative $11 and 61 cents. So we have that concept that we're going to be looking at there. So what now? Well, now we just keep going on, right? This 0 doesn't mean anything, right? I have a negative 1.29 times M. And so to get rid of that, I'm going to divide by negative 1.29 M. And so dividing by a negative, that becomes 1 M, because any number divided by itself equals 1. So 1m, or just simply put m. But if I divide it on that side, then I also have to divide it on this side. And I'm going to keep that symbol with it. So negative $11.61 minus 129. So taking this number and dividing by this number, I went right into my handy dandy calculator and came up with a solution of 9. And so in the end, I can, or whoever this guy's name is, John can buy 9 Sans and still have that $10 left that he wants. Let's double check our work and see how we did. All right, looks good. Okay, so we see we were subtracting, right? Subtraction property of equality, right? So do it to one side, got to do it to the other. All right, and then we're using the inverse operation for the division property of equality, right? So once again, so here we're dividing by negative 1.29, and that's exactly what we did. So they got D, said D equals 9. All right, so that takes us through example 2. Next is example 3. All right, example 3 gets into the fact that because math is not necessarily one-dimensional, we can think about it and come up with a solution in multiple ways. Sometimes, as we're learning math, we just choose what we think is the easiest or what seems to be the easiest, and we are very successful with it. But the fact is that there can be more than one way to get to the same answer, and that's good, right? It's good to know that if you don't quite do it the same way as your teacher does it, doesn't mean you're necessarily wrong, right? Especially if you get to the right solution. So what does that mean for this question? It says the number of trumpet players is 2 more than 1/4 of the entire band. How many students are in the band? So we want to look at the algebraic solution, and then we want to also look at the arithmetic solution. And so looking at these two different things. So one perspective is to take it at kind of at face value right away and just say, all right, we got this sentence that we can read, right? The number of trumpet players is, that means equals, number of trumpet players is 18, according to the picture on the right. So 18 is equal to 2 more than, so I'm going to write that as plus 2, and then 1/4 of, that means multiply, band. And band is what we don't know, B for band. How many students are in the band? And so breaking that down, that's just taking it phrase by phrase by phrase. And so that's what we would call our algebraic solution there. 1/4 B plus 2 equals 18. So they have the equals on the other side. But then, of course, we could solve that by combining like terms, right? They're showing how they're subtracting 2 here, which means subtract 2 here, which gives you 16 equals 1/4 times B. And then you're going to divide by 1/4, but to divide by a fraction, you actually multiply by its reciprocal. And so in the end, you're going to take basically 4 times 16. You see the answer down there, 64. All right, so what about the arithmetic solution? If we look at this, there's really another way we can solve this, right? We can first of all focus on solving for B right away. And so in that case, we could say this, B equals, right? And this is where your mind kind of just goes a little bit different direction, right? The clues aren't necessarily right there in the problem as direct, I think, as the algebraic one in this solution, but they're still there. First of all, we have a total number. We know there is a whole band there, B. And we also know that there are 18 students that play trumpet. So we can write, I'm going to put that in parentheses, 18 students, and that is 2 more than the rest of the band. So actually we would be subtracting 2 and then multiplying by the rest of the band. So if this is just a quarter of the band, this 18 minus 2, we would actually say, okay, well that means there are 4 parts to this band, right? 4 sections to this band. So 4 times 18 minus 2. And in the end, we see how that also becomes a viable solution to what's going on and what's happening in this, right? And so a little bit different things. Now, what I find very interesting then is look at the work, right? On the left side, we see how we subtracted 2 right here, right? Subtracted 2, and that's the first thing we do in this problem is the 18 minus 2. And then when we divided by this 1/4, we ended up multiplying by 4 over 1, which is what we're doing right here in the arithmetic solution. So in the end, we get an answer of 64 both ways, but one uses a little bit more algebra. One uses more arithmetic, right? There's no variables, like hidden variables that you have to rearrange anything. And so that's why it becomes more arithmetic. But you also have to kind of sit back and really kind of ponder how to do that rearrangement as you're starting to put that in. So you can kind of decide which one makes more sense to you, if either of them, and go with it. All right. All right. That is example. That is lesson 5.2. Here's a sample for you. Go ahead and try it out. See if you can. Can you figure out both ways, the arithmetic and the algebraic? All right. Longer video, longer lesson, but we get this down and the rest of the unit just flows. All right. All right. That's topic 5.2.